Hello everyone, this is Group 26. We are talking about melatonin and sleep aids. According to statistics, 70% of American adults cannot sleep well at least one night a month. 11 of American adults don't get enough sleep every day. There are some reasons that people cannot sleep at night. Drinking too many caffeinated beverages, taking naps, and using your bed to work throughout the day. Feeling stressed, watching electronic screens, and eating foods before bedtime. And sleep in a bright and noisy environment. Overcome the above problems, you should be able to have enough sleep. Now, one kind of sleep aid called melatonin is on the market. Let's know it together. In the middle of the brain, there is pineal gland looking like pinecone. It is the neuron endocrine secretory circumventricular organ. The pineal gland secretes melatonin, which is a hormone. Based on the day and night rules, melatonin is secreted more at night and secreted less during the day. When melatonin decreases at night, people suffer from insomnia. As the age increases, the secretion of melatonin will decrease. It is not difficult to explain that our grandparents get up earlier than us. What kind of people can take melatonin? When you are crossing one or two time zones, when you occasionally work night shifts, your sleep-wake cycle will completely lose balance. You can take a tablet of melatonin to regulate the biological clock. How much melatonin do we take? The dosage depends on the age and the specific sleep issues. In general, the safest dosage is 0.5 to 10 milligrams per day. It is best to start with a lower dosage at the beginning, then increase the dosage day by day until you sleep well.
You may be wondering, what's in a melatonin supplement? Well, the answer is it depends on the type of supplement you decide to take. For tablets, there's 4 major ingredients. You have a filler, melatonin. You have a dissolution excipient and a coating material. The dissolution excipient oftentimes increases bioavailability of the melatonin and promotes stability so that it doesn't degrade while on the shelf. A coating material is only used for different types of supplements. For tablets, it's important, but for liquids, you don't necessarily need to have it in the formulation. So you could have melatonin capsules, you can have gummies, you can have soft gels, but the ingredients throughout all these types of supplements do vary. Melatonin is synthesized in the pineal gland, but it is also synthesized in the retina due to a light-dependent feedback system. This means that when it's dark out, melatonin is produced through the retina's ability to sense light. This isn't the only method that melatonin is produced in the body. In addition to a light response, our sleep-wake cycles are also playing a role in how much melatonin is produced in our body. Together, these two factors help to determine how much melatonin can be in one's body at any given time of day. So how is melatonin broken down? Once it's absorbed in the GI tract, it enters the bloodstream to be transported to various cell signaling receptors in different parts of the body. We're going to be looking at receptors MT1 and MT2 in the SCN region of the brain. These are a type of G protein coupled receptor where a ligand will bind, and that will initiate the transformation of GDP to GTP, allowing the subunit of the G protein complex that carries the GTP to attach to the adenylyl cyclase. This binding induces the cyclase enzyme to be able to break down ATP and produce CAMP. Melatonin acts as an inhibitor for adenylyl cyclase, so this reduces the amount of ATP that can be broken down and the amount of CAMP that is present in the cell. So what does this mean for our energy levels? Well, with a reduction in the amount of ATP being broken down, that means lower energy. So the rate at which cellular processes that are dependent on these energy sources, they will decrease, the rate will decrease. And that's why we get sleepy. These are some other sleep aids that have a different mechanism of action from melatonin. So apigenin and chrysin are very similar. The main difference is that apigenin has that hydroxy group off of the benzene ring, but both of these act as GABA receptor agonists, similar to benzodiazepine compounds, and they promote relaxation and anxiety reducing properties.
Hi, my name is Randy. I'm going to talk to you about GABA receptors. So there are two types of GABA receptors. We have GABA A, which is ionotropic, and GABA B, which is metabotropic. GABA A receptors are ligand-gated chloride channels. This is the top view of a GABA A receptor. Upon transmitter binding, they open and allow chloride ions to pass through them and to flow into the neuron, making it more negative, making it more hyperpolarized, which make it less likely to generate action potentials. With GABA B receptors, as shown here, they activate potassium-gated channels that allow positively charged potassium to flow out of the cell, resulting in the same membrane hyperpolarization as the GABA A receptors. This control of hyperactivity reduces responsiveness, thus it can reduce things like anxiety. Common types of A to D are Ambien, which is the structure here also known as zolpidem, which is a non-benzodiazepine Z drug, which acts as a sedative and hypnotic. It works by increasing GABA A effects in the central nervous system by binding to those GABA A receptors. And we also have Lunesta, as shown here in the structure, which is also a non-benzodiazepine sedative. And it works similarly to Ambien, however, it's taken at a lower dosage due to it being a longer acting drug. And that's the two there. And that's all we have for you today. Thanks so much for watching.